Hello everyone, so in this video let us talk about a medium level problem from LeetCode. The problem name is out of boundary paths. So reading to the problem statement, it states that there is an m cross n grid with a ball. The ball is initially at the position start row and start column, which is given to you as an input. You are allowed to move the ball to one of the four adjacent cells in the grid. You can apply at most max moves to the ball. So you are given how much moves you can do and take a ball and move it in any four directions accordingly in this max move number of chances. Now, given the five integers m cross n, the dimensions of the grid, start row is start column, that is the position of the ball, the start position, and the max move, the maximum number of moves you can do for the ball. Return the number of paths to move the ball out of the boundary. Okay, you have you can do at most this number of moves, and you have to move your ball out of the boundary. How many such possible paths are possible? It can be pretty much large, so you have to return modulo that is 9 plus 7. Now, how you can do that? It's pretty much simple. As you can see here that you are given a grid like this. Now, what you can see here is, let's say you start from any position. Let's say you start from this position. Now, you can go this direction, this direction, this direction, and this direction. So at every position, you can go to certain directions and you have to decrease your max move by one because you have done one number of moves. Now, it just assume that you have this as a starting point and you have, let's say, a certain number of max moves. So as you can see here that every point is a certain starting point. You can assume that because you can start from any point. You have a certain column, certain row, and a max move. So these three values defined a particular state. If you have a certain state and that state can be reused, then you can directly use DP here. Okay, so it directly hits when you read the problem statement that you can start from any point. Okay, so every point is defined by 3 points, three things where you can start from, like starting row and column, and the maximum number of moves you have at that particular point. Okay, and if you land to the same block with the same max move, then you can reuse that value because that's a particular state. So when you are defining with states, you can use DP here. Now, what's our use case here? That we will make a grid like this of, because we have 3 points defining a state, and as you can see here that the constraints are also pretty much small. 50 50 50, so you can make a grid like this and then you can do DP on top of it. So what we'll do DP here, that we will start from a particular position and we will keep on proceeding and doing a recursive function until we will exhaust this number of max moves. So we have a particular state defining a starting position, the starting row column, and the number of max move we have at this particular point. From at every point, we can move to four directions: left, right, bottom, and above. And then that encounters as one move. Then you have the next move. You will recursively do this. And if you move out of the boundary at any point, then that defines one path, and you will keep on storing it in some grid, which I've told you, which is of DP, which has three, you can say three parameters defining a particular state. So that's the complete thing that you have to do. Nothing much complicated here itself. You will understand it very easily when you go to the actual code part and the question statement as well. Let's move on to the code part now. What we have done here. So what we have done is that we have to first initialize a DP. You can say DP memoization. You can say state. So for that particular thing, you have to store all these states inside some, you can say, a vector. So you have a 3D vector, and in that vector you have the maximum 50. So I've made it a little bit more buffer. So 52, 52, 52 is that the size of the DP table of 3D vector. Then what we have to do is that we initialize everything with -1, that we do not have iterated over any of these situations, and we will find it out the answer as we move accordingly. Now what we'll do is that we will start a recursive function. So a deep, like when we try to do DP, it's just that we will do a recursive function and just add memoization on top of it. So what we're trying to do is that we are starting a check function that starts with the starting row and starting column that we are starting with, that is given to us, the max move and the m cross n. Now what we are trying to do here is that if we go out of bound at any position, as you can see here, then we return one, that we find out one of the valid path. If we have exhausted all of our max move, we return 0 because the maximum of 0, then we cannot move and we don't have any valid path if we have not gone out of the bound. Okay, if you have gone out of bound, we will get one answer. If you're not gone out of bound and we have exhausted all our moves, then we return 0. If we have seen an already state, this is for DP, let's just assume, like, ignore it here, let's move down to the recursive part here. So for every state, if we are inside, if we have gone outside of the bound, then we will take it, add it to the 1 to the answer, and then we just got that we have got some answer that we have gone out of bound. If you are inside the bound, then we have 4 directions we can go to: up, down, left, right. So we'll recursively call this function again with, because we have done one move, so our max move are like decreased by 1, and because now we have like moved up, so as you can see, start row decreased by 1 and the column doesn't change. If you're down, then start row like increased by 1 and the column doesn't change. Similarly, left and right. That defines out all the particular recursive states that we'll go to again and again, and move all the other states left to right. Okay, now in the end, what we have to do is that we have to find out the answer, that is the sum of all of them, up, down, left, right, because all of them can return any possible path, and all the paths, if we found out one valid path, it will return 1. So we have to do the sum of all of that. So we will do a sum of all of them, as you can see, but we have to do a mod with m. So we'll do, if you have no modular arithmetic, we have to do modular, like mod m, and the whole mod m. So that will be easily to find out the complete mod value. You can do mod m here as well, like this as well, but nothing much required here right now. So what we have done is that we have found the answer. Now that's the complete recursive part. Now if you were to do memorization on top of it, we have to store the states. So the state defines out by the row, column, and the max move we have at that particular point. So that defines out a state. We will store it, this DP state, before returning our answer. And if we have, like, going to the complete recursive part, if we have already seen that particular state, that it is not equal to -1, that we have already seen this state, we will directly return that particular state without going to the recursive part. So this and this part is used to add memorization on top of it. If you just remove that, then memorization is just removed. It is just a recursive function. So that's a complete recursive function, just plus memorization, and that is how you will use DP to solve this particular problem out. If you still have any doubts, you can mention in the comment box for this particular video. I will see you in the next one. Till I keep coding, and bye.